Hello and welcome to part 8 of the book summary. Today, we are going to briefly look at code overlays. Be warned though, this is the most technically demanding chapter that I found so far, as the reader is assumed to have a prior knowledge of this topic itself. In essence, code overlays is a programming technique to overcome limited memory situations. But, what are code overlays? The name itself is quite confusing, as it literally means covering a code. So, what is it exactly? What's the technique that we're going to use? According to Wikipedia, it's the process of transferring a block of code or other data into the main memory, replacing what is already stored. This definition itself is rather ambiguous, as what can be considered as main memory, and what are we replacing exactly? Let's approach this with a problem-solving mindset. Imagine a situation where there is not enough memory in a computer or microcontroller to load our program. So, we must find a way to get more memory. One way to do it is to load some sections of the code to an external memory, which is in this case an SPI flash storage chip. Then, have a special section of memory in the main computer itself, like the blue pill, dedicated to loading code from the external memory. This section of memory does not need to load all the code stored in a flash storage chip at one go. Rather, it just loads the codes that the computer needs to use and run at a point of time. Therefore, we are able to overcome this limited program memory situation by loading some sections of the code into an external memory and execute them when we need them to. Do take note that means that we must have a program code that does the functionality mentioned above, or mentioned just now. So, to repeat myself again, in essence, we are dealing with compiled code and figuring out a way to load them to an external memory and then executing those compiled codes. Thus, let's take a quick review of the typical compilation process to understand that the methods we are going to use later better. We all know that computers do not speak human language. Therefore, we need a compiler program to translate what we want the computer to do in machine language. The steps are usually something like this. We take a piece of code and use a compiler, such as GCC, to compile them into objects files. Then, these objects files are then linked into other objects files from the libraries that we use. The resultant file is usually an executable or a binary, which we could run in our computers. This is a bit different for the case of the STM32 blue pill, as the resultant file is not an executable or a binary. Rather, it is an image file which we are going to use and flash it into the blue pill itself. Knowing this fact, that means that somehow inside our code, we must tell the compiler and the linker that an external memory exists, and we are going to load code from there and execute it in the blue pill itself. So, in the book, this is done both in the C code that we write, the Makefile, and the special linker script itself, which we are going to take a look at next. So, Make is a program that automatically compiles and builds executables from source by reading Makefiles. If we look into the Makefile, there are several lines of codes here. These are the files that we need to compile, and then there's this specific line here that tells Make to run this linker script. Now, let's take a look at the linker script. The script uses the linker command language, but the basic idea is this. The role of the linker script is to combine multiple files into a single file. And this is done through a couple of commands which you can use. If we take a quick look at the file, we can see that it's quite daunting with a lot of abstraction going on. But let's zoom in at one section, the memory section. This part defines where the code is going to be loaded into the blue pill. It specifies the starting address of the memory to store the code and the size of it. So our main code in this case, which is ROM, read-only memory, is loaded into the starting section of the flash memory in the blue pill, shown in this address here. Then, the memory for our stack space is loaded into the starting address of the SRAM. We have also defined a special region called the overlay region in our SRAM. This is to execute code stored in the flash storage chip itself. And finally, in our linker script, we specifically mention the starting address of the code that to be loaded from the flash storage chip. In this case, it's the 0th memory, assuming that we store the code section there. So that was quite a bit to go through, and to be frank, there is more to this chapter, as you can see from the list of key terms here that I found out. And I think it's better to look it up on your own, as it's not thoroughly explained in the book. Who knows? Maybe you could perhaps explain it better or stumble upon a better resources on your own. With that being said, I would like to point out some useful references you might want to look into if you are curious about this subject more. And that's all for today. Thank you, have a nice day, and goodbye.